So picking up where we left off, we've derived two important limits that we're going to need in order to do the proof of the derivative of the sine function. Okay? So let's go ahead and find the derivative of the sine function. Here I say it will be the cosine of x. That's interesting. Okay? Let's see what happens here. So if I have f of x is equal to the sine of x, then f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This is equal to the limit as h approaches 0 of the sine of x plus h minus the sine of x all over h. So typically, I've not asked you this limit problem before because it's a tough limit problem. Typically, our goal is to somehow find a way to finagle this h out as a factor somehow and then cancel it with this h down here. That's sort of the general strategy of these limit problems. But you can't do that in this case with these trig functions. There's no nice way to get an h out of there. Okay? So instead, we're going to try some of our trig identities. Okay? The first one I'm going to do is the limit of, is the sum of two angles within a sine. Okay, so that's this identity right here. I'm going to go ahead and use this. Okay. So it turns out that the sine of the sum of two angles can be written as the sine of x times the cosine of h plus the cosine, let me keep them this way, plus the sine of h times the cosine of x. Okay? So all of that is what I just did with this expression right here using my sum of angles identities. Minus the sine of x, that's just that lingering one, all divided by h. So it's not clear that we've gotten anywhere closer, except notice that the x's are no longer attached to the h's, and in some ways that'll be beneficial. Okay. So let's give this a shot here. I'm going to go ahead and group, so I'm sure I've got this right. X, yeah. So if I had a fraction, it's up here so the viewers can see. If I had a plus b plus c over d, I could rewrite that as a plus c over d plus plus b over d. So I'm going to rewrite it to look like that. Okay, so I'm going to collect together this first and last term and put it over h, and put the middle term also over h, separate them by addition. So I'm going to group together the first and last term and put them over h. That gives me sine of x cosine of h minus sine of x over h. And then I'll go ahead and distribute the limit over those sums. So then that's the limit as h approaches 0 of the middle term all over h. Okay? Now, there's a couple of slick tricks in here that I do often test with true or false type questions. All right. So this is a slick trick. Okay? Notice that this factor right here, sine of x, and this factor right here, sine of x, I got common factors. I could factor them out of the fraction, but I can take that one step further. We saw this in a previous problem. My limiting variable is h. So even though the sine of x in both those terms it's a variable as far as x is concerned, it's not a variable as far as h is concerned, so it's like a constant as far as h is concerned, so I can pull that factor out of the limit. So let's do so. That would give me the sine of x times the limit as h approaches 0 of the cosine of h minus 1 over h. Plus, over here it's same but not quite as complicated. I've got a factor of cosine of x, that does not depend on h, so let's factor it out. This gives me cosine of x times the limit as h approaches 0 of the sine of h over h. So folks, we're done. This is the sine of x times what? This limit look familiar? It's this limit right here, right? But with h's instead of thetas, and that limit came out to be 0. Times 0. Plus the cosine of x times this limit here. What did this limit come out to be? Everybody, all together? 1. So we just get the cosine of x. Really interesting, folks. The derivative of the sine curve is the cosine curve.